What are you looking at? Strike a pose. Strike a pose.
When you think of physics, I'm sure the idea of fashion does not come to mind. The truth is, no matter what it is, sports, music, or sunbathing, physics is present in every part of life. As you see in this fashion show, designers hire tall, thin models to show off the clothing. They do this so that the models look like hangers, and the people viewing the show will only pay attention to what the model is wearing. The physics of light and color play a huge role in fashion. When you look at a model, she is wearing clothing that is created from different dyes and pigments that create the color you see. There's another aspect that contributes to how we see the clothing: light. Isaac Newton made an interesting discovery involving white light. He found out that white light is made up of all colors of light combined in equal intensity. When white light is separated through a prism, it creates a continuous spectrum of colors. This is how a rainbow is created. What's the connection between a prism and a rainbow, you ask? Well, think about it. A rainbow occurs after a summer rainfall, and the prism is the droplets of water that are left over in the sky. Let's get back to the fashion show. In fashion shows, the lighting pointing down on the models, along with the cameras flashing, all contribute to how people see the color pigments of the clothing. There are two very important principles in physics at play in a fashion show. The principle of color addition determines the ultimate color of light that we see when many lights are on at the same time. The principle of color subtraction determines the color of the clothing. Let's look at each principle one at a time. What you're looking at right now is a color wheel regarding light. This shows the three primary colors that make up white light, but also what the primary colors make when they are combined. This is the principle of color addition. For instance, red and blue are combined to make magenta, while red and green make yellow. Green and blue create cyan, but what's most important is that when red, green, and blue are combined, they create white light. This is exactly how a color TV works. It happens to be made up of only red, green, and blue phosphors. You might be asking yourself, then how can a TV have more color than just red, green, and blue? It's because the phosphors combined in different intensities to create the other colors needed. Again, color addition at play. Let me demonstrate. Right now, white light is on me, so I look pretty normal. But if I shine a blue spotlight on me, I look like this. Then, if I take a red spotlight, I look like this. Using color addition, I can put the red and blue colors together, and it creates a new color, magenta. Let's start over. Red spotlight, please. And now for a yellow spotlight. And when you put them together, the result is orange. The principle of color subtraction is a little different. Instead of adding different colors of light, color subtraction is when you add opaque colors, such as dyes or pigments, to create a new color. This is how they create the pigments for clothing. So, like the light example, I am going to take red and blue, but not light. I'm going to take pigments or paints. So, I'm going to take a blue paint and a red paint and mix them together, and I should come up with a magenta color. Let's see how it turns out. Need to add a little more blue. And there we have it. Now, it all depends on how much red and blue you add to create the color of magenta. If you added a little more red, it might turn out a little more reddish magenta. If you add a little more blue, it might turn out a little more blue tint. Let's try another example. If you take red and mix it with yellow, we should get an orange color. Let's see if it works. A little more yellow. And there you have it. Color subtraction also occurs when an object absorbs all the color of light except the one it shows. For example, a leaf. Because of its chlorophyll, the only color the leaf does not absorb is green. Therefore, it looks green to our eyes. Let me show you another example. Here are my cousins, Sarah and Katie, doing some painting. This scene looks totally normal to our eyes because white light is reflecting off of them and coming into the video camera. What do you think the scene would look like if I put a red gel over the lens? I'm sure you're not surprised that everything turns red, but do you know why it does that? Because the red gel has properties that make it absorb all the colors of the spectrum except red. So this allows only red to pass through the video camera, making the scene look red. This principle also applies to sunglasses. When you add a different colored tint to the glasses, it's like the gel making the scene a new color. So, as you can see, not only does color subtraction and color addition take place in the fashion industry, but plays a critical role in how we view the world around us.
What are you looking